Hi everyone, hope you had a lovely Christmas. So today we have a new video. Must be 4 weeks since I uploaded one now. This video is not so much one of my projects, but it will be quite interesting. So, where do we start here? So, just ignore the traffic going up and down the road. I'm not going to stop talking when the traffic's going up, try and keep my voice good and loud. So we have 2 Rotabroach drills. One belongs to my dad, the other belongs to Farmer, my friend, who came to me saying, can I do anything with this drill? Because there's actually an issue with it. Well, design issue, I would say. So it's like a safety feature, but the safety feature's too much. It just makes the drill quite useless. So this is a Rotabroach Panther. So this is much more analog type. So it's basically a switch on and off to turn the magnets on and off. So in the bottom of it, you have 2 magnets on the base. It sticks to the metal, RSJ, plate steel, anything. So if you put a piece of 3mm plate below the Panther, she would stick to it. You just have to sort of keep your hand on it and make sure it doesn't jump around because the 3mm is not that fixed. So the thicker the metal, the better stick you have, more or less. So this is what the video is about. This one. This one's here to demo or to compare the 2 drills in action. So I'm going to do a wee video in a minute on these pieces of steel. So we have 5mm plate, we have 10mm plate, hold on, we have a girder, RSJ, H iron beam. So we're going to test the 2 machines out in both. We have another one, what size is that? 7-inch, 6-inch H beam. So we're going to do a demonstration of the 2 drills on this. So we're just going to compare the 2 really, and then we're going to modify this one. Either electrically, modify the board, or there's obviously a sensor in the base because demonstrate that now. So we'll move these out of the way a minute. So at the bottom of this one too, you also have 2 magnets, electromagnets. The problem is, when the farmer or anybody goes to use this drill and they place the drill on the piece of steel, the drill sticks to it, but it senses that the metal, the gauge of the metal is not deep enough. It's like a safety feature. However, if you were to use the handle, the rotary handle, to drive the drill into the steel, it doesn't fall off. The drill's more than capable of actually boring the steel, but cutting the steel. But the problem is, it's a safety feature. So it's looking for metal of a more dense, more deep depth, bigger depth. The back of it. Let me get my words out there. So basically, like a 10mm plate on the back of the RSJ. So sometimes what the farmer has to do is, when the magnetic drill is stuck to the H beam, they actually have to put more steel behind it to get the drill sensor to kick in, to engage the digital circuit. So what I'm going to do here now is I'm going to do a demonstration. So this is more digital, this is a more modern type drill. This here is probably 8 years old. I'd say the new Panthers now have this digital circuit. Makes the drill quite useless to anybody doing, structural work on smaller girders. Bigger girders would be no problem. H-beam, the thicker the better. So I'll just mention here, so this one here, this smaller drill is an Element 30. This has I think it's a stroke, a cut depth of 35mm. There's the rain now. It has, you can put a cutter in it up to 32. This one can put a cutter on the Panther up to 40mm, and it has a cutting depth of 50mm. So that's all the comparing I'm going to do between them. What I'm going to do now is demonstrate the Flaw in this one, and I'm going to demonstrate how this one is capable of sticking. So this is like older technology, is capable of sticking to thinner gauge steel such as 3mm or 5mm, which this one doesn't. So this one, when you put it on steel, will engage the magnets. However, it doesn't allow the motor to start up to do your cutting, basically. So anybody that tries to use it gets frustrated, obviously. And so we're going to demonstrate this now happening. The rain came. So delays. Okay everyone, we're going back out here now. Another wet weather. So I'm going to try and do this now before it starts raining again. So what I set the camera up. So the two drill machines are below the bench. And that's ready to rock now. So we're going to start. Oh, it's heavy. But there. Oh. We're going to start with the Panther. Ah, it's so heavy. I have a sore back. Right. So hopefully you can see them now nice and clear. So what I'm going to do first, right, I'm going to plug this camera in just to keep the battery's quite low on it at the minute. So that's us ready to rock. So let's go. So the Panther, right, so the Panther sticking to anything has no problems. There we go. It starts up to drill, to cut. So the Panther has no issues. So what I'm going to do here is I'm going to set the Panther on top of a bit of 6mm plate. This plate. And you'll see how she sticks to it. Magnets on. So basically I turn the magnets on, off there now, by turning this wee switch. So there we go. See it pull on there. So we can turn it on. And she has no bother cutting the plate 6mm and the magnets stick well. So what I'm going to do now is I'm going to move on. I'm going to demonstrate this cutting 3mm plate before I move on to the problem. So the 3mm plate I'm using is just the bottom of an exercise machine. So you can see there that's 3mm thick approximately. So, oh, so don't tumble that one. So magnets on. So you can see there that the drill has no problems sticking to the 3mm plate and cutting it. So that's us finished with that one, which is quite heavier. Thank goodness, my back's sore. Right, what I'm going to do here now is we're going to move on to the Rotabroach Element 30. So this is where the problem begins. So here we have the Rotabroach now sticking to the 3mm plate. I know it's not going to stick to it because it doesn't. It sticks to it, but the drill doesn't start up. The digital circuit does not allow the motor to start up because it detects that the metal's not dense enough or deep enough. So if I turn this on now, that drill is stuck to the 3mm plate. It has no bother a bore. It would have no bother boring it or cutting it, just like the Panther. But this new safety feature in these digital drill devices is, well, not everything. So basically it doesn't let you the drill to start. It's just like a safety feature. So the drill's isolated. The safety circuit has made the drill useless. That's just how the best way to put it. It just makes it useless. So what I'm going to do here now is I'm going to demonstrate this on a 6mm plate. So we're putting the 3mm plate away. We've got the 6mm plate. So make sure the plate's nice and clean, which it is. Again, drill on. So we have to energize the magnets first. So you push this, we have no green lights. So that's basically saying that that piece of metal is not thick enough for the drill. the first time I used one of these, I just like, well, shook my head side to side and going, what is going on? Clearly things, well, years ago were built better. All these new safety features now and things like this is causing problems, and even tools. So this drill does not start, won't let me bore a piece of 6mm plate. So that means that this drill is quite useless to anyone doing structural work on shades, what else? Fabrication work, which I use that Panther for. Like, it just makes it completely useless. It's quite shocking, really. So what I'm going to do now, so say that you wanted to bore a hole in a bit of 6mm plate. What you have to do to bluff it, to bluff the circuit, is put something heavier behind it. So once I drop that 6mm to that 10mm plate, the drill will engage the circuit. So there we go, there's the green lights on, and the drill now can bore the 6mm plate. The only reason the drill is jumping is because there's actually a tooth missing out of that cutting tool. But it's not jumping that much. But you can see how well the magnets stick to the 6mm plate. They have no problems with that. So it can stick to it the exact same way the Panther can. But it's just this new safety feature. So what I'm going to do here now is I'm going to move on. I'm going to demonstrate. It sticks to 10mm plate, no problem. Doesn't stick to 3, doesn't stick to 6, a quarter. So here we have an RSJ now. So basically this is what you get in the farmyards around where the, I don't know, where the cows are based and through the sheds. You have these RSJs between walls and stuff. So see this hole that is actually bored in this RSJ. If the farmer wanted to bore a hole, let's say on the opposite side of that hole. So about there. So say now when the farmer goes to start this, it started that time, alright, okay. However, it is, you keep in mind here that this here RSJ is about 8mm thick. You get the RSJs that are 6mm thick at this point, and it is actually about 5mm thick here at the middle. So I know now that this magnetic drill will not stick to this inner part of this heat beam. It's only sticking here because this RSJ is 8mm, but you do get lighter gauge RSJ at this point. I don't have any here, but I'm just going to show this here. So say now if I move this drill the slightest way, this direction, which I have done there now, that drill won't engage the motor. Won't engage the motor. So say if you wanted the hole at that position that's at there now, won't engage. So we'll turn it off. Now we're going to demo, oh, let's say we want to put a hole here. 2 holes here or whatever in the middle of the heat stream. So I go to turn that on, look, it's stuck dead. But the drill won't start. I think I've done enough demoing of how well a flaw in this machine. I call it a flaw, anybody else would call it a safety feature, but you know, who's going to take their hands off a drill when it's in the air above their head, when it's already sticking to the magnets? Like, it's, I just sort of the older ones done that, like, so it makes no sense to me. Here we have another beam. So here we have 5mm in the middle. This is 8mm on the outside of the H beam, RSJ. If I wanted to bore a hole here, I would have to go pull Panther out, the bigger drill, because you can see here that it is stuck to it. But you go to switch the drill on, the motor, no green light, not working. So what I'm going to do now, right, is I'm going to demo, oh here, I'll just bring the Panther over 2 seconds again. So here's the Panther on the same piece of steel. So no problems with it. You can see there that I started cutting. So what I'm going to do now is I'm actually going to... I done enough talking about that, didn't I? Right, so I'm going to get this camera up a wee bit. So I'm going to take the drill apart, and I'm going to bluff. I'm going to bypass the safety feature to make it act like the Panther. So basically the drill will always start up, the motor will always start up, as does this one. What do you see? So if I take this away from the steel, it always starts up. At the minute, obviously this one doesn't even start up on a 6mm plate, so it's not going to start up in my hand. So here we go. Not going to start. So what I'm going to do is I'm going to basically have it acting like the Panther. So I hope you enjoy. Okay everyone, so we're ready to take this machine apart now. When I say take it apart, I'm going to remove this cover and the other cover at the other end. So basically that's done using this little T15 torque screwdriver T-handle. So here we go. So we'll get a look inside it and see what's in here. What circuit's in here that's causing this well, really annoying problem. Frustrating problem. So I can see already there's a lot on here. So we have the switches, we have a lot of relays, we have, well, a lot of relays, a wee buck converter, so basically AC to DC, probably for the little magnets at the bottom. So take a side off and see what's on here. So, okay, so I can see. Okay, so I can see two magnets, electromagnets. Two sets of wires, positive and negative, going to them. I can also see a sensor, which is embedded in the base of the drill. So I think it's better for me to take this face off to get a closer look at the circuitry in here first, before I start thinking about a way of modifying this. Okay, so here we have the control side. So this is more like the all low voltage stuff here. We have these switches that aren't latching switches, momentary switches. So what do you see now if I bring out this board too? I don't know how many screws is holding this in. So what I'm doing now is I'm bringing out the control side of it. The circuit that switches the electromagnets on and the drill. See if I can get this out here without breaking anything. There we go. So, okay. So we have 3 relays. One relay on the sides to control the motor of the drill. These 3 relays. One of them's for the magnet number 1, the electromagnet, and the other one's for electromagnet number 2, I assume, right? We also have a fuse, capacitors, transistor, right down here in my thumb is. So basically, we have a sensor coming up here, 2-wire sensor. I plugged it out here at the minute. So this sensor is more likely Hall effect sensor, and this sensor is triggering this transistor, which turns the drill on, or allows the drill to be turned on, the green light. So basically when this transistor switched, it means that the green light's on. So what I'm going to do here is I'm going to sample first, see what type of sensors are embedded in the base. and try and bluff circuit. So basically, on the, sorry I moved the camera there, on the other side of this, in here, if I was to take out these star screws, there's going to be some sort of digital controller, which is in here. I'm not going to go near this, so I'm not going to interfere with the drill. I don't want to sort of disadvantage the drill, so the drill can be put back to its standard ways after this. So I'm basically don't want to be destroying the board or cutting tracks in the board, or basically what I'm going to do here is I'm going to bluff the sensor circuit. So I'm going to basically say that there is 10mm plate at the sensor all the time. To do this, I'm going to, well, I hope it's going to work. So to do this, I'm going to remove the sensor out of the base. I'm going to maybe rest it against this steel base. Use the drill as the plate. So basically I'm going to have the sensor sitting. Where did I get something here to demonstrate this? So this is the base of the drill. I'm going to get the sensor, pull the sensor out of the base, set the sensor against the thick bit of steel that's at the base already, which is this 35mm well, it looks like cast steel. It's probably just steel actually. So to do this now, I'm going to remove, if you can look in here closely, what do you see here if I bring the camera down here 2 seconds? It's starting to rain here now. So if you look in here, yeah, it's raining there now, I'm just going to sit through it. So you have these 2 cables, one of them's going down to coil number, electromagnet number 2, electromagnet number 1. We have this sensor in the under with a 2 red wires going onto it. So what I'm going to do is I'm going to lift this bit of glue. Let me see if I can get a better angle here. Yeah, so I'll turn it around, hold on. So see this sensor in the under? I'm going to remove this bit of, I'll try and do it here now with the camera, sorry I was going to say phone, the camera in my hand. So, see this bit of glue, what you want to do, right, is remove it. Stick a screwdriver below it, pop it out. There we go, it's stuck to the screwdriver now. Then we'll be able to see, well, 2 wires still. You'll see a sensor embedded way into the base. So here we have the sensor now. They're starting to rain there now, sadly. So what I want to do here now, well, is try and see if this is going to work. So we have a sensor, pretty much more like a Hall effect sensor. So this sensor controls, well, I assume it controls this transistor. So when this transistor base gets enough voltage, it switches between the collector and the emitter, allowing a current to flow, which then obviously engages the safety circuit. Disengages the safety circuit. So I'm going to stop here for a wee minute because I'm put this drill away because it's actually lashing on top of me now. I'll start in a wee minute again. Okay everyone, so set up again now. No rain at this point. So what I'm going to do now is I'm going to demonstrate the sensor against the base of the machine itself. So what I want to do now is I want to bluff the machine. So here we go. So then I'm going to place the circuit back on it. So this Hall effect sensor, well, it's a type of sensor which detects the presence and the magnitude of a magnetic field using the Hall effect. So what do I demonstrate this? So here now, if we place the sensor close to the base, you can see it engaging the green light on and off. So what we want to do is we want this green light on all the time. So to do this, I have raised the sensor out of the base. So when you attach plates onto the bottom of the base, it must be altering, or well, it obviously is a varying the signal from the Hall effect. So what I'm going to do now is I'm going to find a new location for the sensor to sit on top, or inside the drill, on top of the electromagnets. So first things first, I'm going to place this circuitry back on the drill itself. I'm going to turn it off here first. So placing this back onto the drill without breaking any of the wee wires. There we go. So that's it, finished. Well, the circuit board's in. Next step now is turning it on again. So, what I want to do now is use, well, as I mentioned, when it started raining there, I could bypass the transistor, but I'm not going to do that. I'm not going to interfere with the drill's PCB or the control side of the circuit, the safety circuit. I'm basically going to get this sensor. I need to watch because the drill's still on there. I need to get this sensor and face it perpendicular to the base in order to keep the green light on all the time. So basically I can turn it off with a switch, turn it on with a switch, turn it off, just like the Panther Rotabroach drill. So it seems like I've got a good location here to side. Like a bird on a tree. So I'm obviously the presence of a magnetic field, it's engaged in the circuit. So when you attach the plate to the bottom of the device, it must interfere with the magnetic field. So anyway, we're not going to go on to that. So what I'm going to do now is place a bit of epoxy around the sensor and, well, clean the bottom of the drill first, make sure there's no oil so the glue sticks, and hopefully this is a fix. Well, bypass. Here we go. Okay, so removing any dirt. Turn the drill off first. So removing any dirt from in here. Let's see if I get a good angle here. So basically I will be placing the sensor there, facing down. So mix a wee bit of epoxy up here now. So this is just a 2-pack epoxy Gorilla Glue. You don't need very much. That will do it, I think. A wee bit more, do no harm. So I've got a Stanley blade here to mix it. There we go. So this sensor's new location will be, well, until the drill's no longer in use. Mixing this up. So what we're going to do now, I don't know if I want to place this right round the sensor, but this will turn clear, believe it or not, when it's setting. So that's it. Never seen it going that white before. It must be a bit of water in that cardboard. So what I want to do now is place a bit of this epoxy around the side of the sensor and around this side to make sure it's not going to come off when it's dropped, and you know, so this can be took off in the future again, well, with a knife. So that's it, ready to be its new location. Is at the side wall here. So I need to hold this in position. Well, have something resting against it. Okay. Let's stand her up straighter. So we're just going to test that now. before the glue sets. You're plugging her in, making sure the light goes green. Perfect. So we'll let that glue set and then we'll screw her back together and we will test it on the pieces of steel that we started, well, used at the start of this video. So hopefully it all works out. Okay everyone, so you can see the Hall effect, well, the connections, the sensor, I have now moved to the side of the base, the top of the base that's attached to the side of that casing there. So what I'm going to do here now is I'm going to place it back together, the entire drill. Then I will do the final testing on the magnet, starting up on 6mm, 3mm steel, and see how it goes. So I'm going to plug it out here just to bear with me here because it keeps raining on me and I like to do it outside for more light, this sort of thing. So sensor is in place. Not be long. Okay, so that's the switches back in position, the wee panel. So what I'm going to do now is place the two side covers on the actual, this casing. So the sensor is attached nice and firmly. So finishing off please. Okay, so final casing, or side plate even. Okay, so now we are ready to test this drill now. So we're going to start with making sure it still works on 10mm plate, and then the most important plates, well, where the issue lied, it didn't switch on 3mm plate and 6mm plate. So now I can sample that with the 3 plates. I might bring the girders into it too. So I'm just going to plug this camera in here. Okay, so that's us ready to test. So we're going to start with 10mm plate again. So as you can remember from the start of this video, it had no bar sticking to 10 or switching on at 10. Still switches on at 10. Good. Happy days. So now moving to 6. So this is where the problem lied. It wouldn't stick to 6mm plate, quarter ball plate even. Here we go. So this is the moment of truth. Perfect. Switches on, the green lights. So as you can remember from before, the magnet's always engaged. But the safety circuit was keeping the drill from starting. So it starts there now, and I can bore away. So, as I mentioned before there, that drill's got that cutter's got a tooth missing on it. And also, do you see this guides down the side of this drill there, the way the head's shaking side to side? They should be tightened up a wee bit too using a wee, I think it's a 4mm Allen key. 4mm, 3mm Allen key, 4mm. So I'm now going to move to 3mm plate to see if it works, which obviously it's going to. So this is the 3mm plate, the bottom of the exercise machine. So if you were to go and pick a new one of these machines off the shelf now, it would not stick to 6mm plate, or definitely not 3mm. Definitely not 6mm too. I should just make that clear. So now if it'll stick to it but it won't turn on. So as I've mentioned hundreds of times. Okay, so here we go. So there we go now. She's sticking to the 3mm plate. Well, she's switching on the 3mm plate. So again, if I was to lift the drill into there, look, that is no bother boring a hole there with a new good cutter on it. So I will test it here. I'll change the cutter in that drill because it's done, and then I will do that again. So I just changed the cutter. As you can see, look, there's a big bit missing there. That one, that's the reason she was jumping about. It was nothing to do with the weakness of the magnet. There's actually well, there's 4 cutting teeth on it, and there's 1 completely missing. So I just changed, took a cutter out of my dad's Rotabroach and put it on this one instead. So what do you see now? So switch on. The magnets are engaged. The green light comes on straight away this time, because I have bluffed the machine. So here we go. We'll start cutting. So that's brilliant. Turn the magnets off. So you can see there now that that machine has no problems drilling in 3mm gauge or 3mm thickness steel. So luckily I didn't hit that channel there, but that's okay. So that's it, everyone. Okay, everyone, so that is everything. Well, that's the video wrapped up. Thank you for watching, everyone, and I hope you enjoyed. I hope the farmer enjoys his lovely adopted drill. There will be more interesting projects coming. Well, obviously this is not a project, but something for the channel. There will be more interesting projects coming in January. Hopefully when we get better weather. I have been on and out of the shade today like a yo-yo because of the wet weather. And yeah, so that's it. The drill now is easy, so I can actually turn the drill on in mid-air like the Panther. So mission accomplished, and yeah, so that's it. More interesting projects in January. Thank you for watching, everyone, and I'll see you all later.